On the last part of representing probabilities, we're going to look at Venn diagrams. Make sure that you've seen the previous videos to understand how you can use different diagrams to represent probabilities. In this video, I'm going to assume that you know how to write in values inside Venn diagrams, so all we're concerned about is the calculating probabilities. One thing to note before we start as well is that if you remember the and the or rule, so if I say probability of A and B, in Venn diagrams, this translates to A intersect B. In normal calculation, the and translates to a multiply. And then for P of A or B, we're looking at the union. So we have the probability of A union B. So in mathematical notation, this is A plus. So just something to note that you could use these facts for Venn diagrams. So if I have a Venn diagram, I have a class of 30 pupils, 8 of them like mustard, 24 of them like ketchup, and 5 like both mustard and ketchup. And I want the probability that a randomly selected pupil will like mustard and ketchup. I think you can easily do it without even doing the Venn diagrams. But if you are given the Venn diagram, say, so we have, let's say this is mustard and this is ketchup, and I'm putting the values in. Remember, always start with the center. So how many of them like both? It's 5. And then you start subtracting 5 from the rest of the results. If 8 like mustard and 5 of those 8 are in the center, it means that you have 3 left that only like mustard. And if you have 24 that like ketchup, but 5 of them like both mustard and ketchup, so you have 19 that only like ketchup. And then the rest, remember that's 30 pupils, so the rest has to be 3. That's the remainder. So 13 minus 3 minus 5 minus 19 will give you 3. Now, if I want the probability that a randomly selected pupil will like mustard and ketchup, I'm looking at the probability of mustard and ketchup, so the intersection. So it's 5, but you need to remember that it's a probability, so it's 5 out of how many total pupils? 30, which is 1 over 6. So just to be aware. So take this just as a precaution. You still need to divide by the total, and this as well by the total. So quite an easy example here. But what if we have 3 events going on? So we have this Venn diagram and we have kids competing in different events on a school day. So they've already given us the Venn diagram. We want the probability that a randomly selected child is not competing in the crocodile wrestling. So not competing in the crocodile wrestling, so we are looking at something outside this circle. So outside the circle, so probability of not competing in C is 17 plus 12 plus 32 plus 4, which is 65. But not competing out of how many in total? So you actually need to know the number of children. So the number of children would just be adding up all the numbers in there. That's 15, 32, 44, and 4. So I have 135. So now out of all of these kids, 65, there's a probability that if I pick a child at random, there's 65 out of 135 chance that this kid did not participate in the crocodile wrestling. So this is the probability as it is. Remember, you always have to divide by the total. And this could simplify to a 13 out of 27. Now for part B, it's slightly different because part B would require you to look at a different total. And if you've done conditional probability, then this is it. Given, so that's the keyword for conditional probability, given that a randomly selected child is competing in the egg and spoon race, find the probability that they are also competing in both the sack race and the crocodile wrestling. So I already have the condition that I'm looking at the child competing in the egg and spoon race. So this is my total now. This is the pool of kids that I'm looking at only, not the total. The first option was just randomly selected child in the competition. But given that I'm looking at those competing in the egg and spoon race, I'm only looking at this option. So the total for the eggs is 40 children, if I add all of these numbers up. So out of those 40 children, so because this is the given condition, what's the probability that out of those 40 children, they're also competing in the sack race and the crocodile wrestling? So this is obviously just the 5 here. So I have the sack and crocodile wrestling is 5. So the probability is now 5 out of 40, which is 1/8, or if you want it as decimal, 0.125. If you want the rule for conditional probability, this is the probability of it's the eggs, sack, and crocodile, given that they are competing in the eggs race. And sorry, let's do that they're competing in the sack and the crocodile race, given that they have competed in the egg race. So this, as the formula for conditional probability, if you've done it, is this divided by the probability of E. And the probability at the top, because I have an and here, so again I'm looking at S intersect C intersect E divided by a probability of E, and this is basically the intersection of all of them, so that's equal to 5, and this is the probability of E, which is 40. So hence the results. Just as an extra note, if you want to, you can think of it as, well, the probability of E is, this is just on the side, the probability of E is 40 out of 135, and the probability of doing all of them is 5/135. And so you are dividing 135 divided by 40/135, and this simplifies to 5/40. So if you still want to stick to the proper rules of probability, this is another way of interpreting it. Hopefully this is clear, and you can try and challenge yourself with different questions. So probability is quite straightforward, especially using Venn diagrams, because you've already dealt with Venn diagram. It's just being able to divide by the proper total that you need to be aware of.